welcome back. We'll be solving more series circuit problems here. Just to recap from the last series video, all the resistor values were given, so you ended up solving for the same component over and over again in Ohm's law. But realistically, on an exam, this won't be the case because the goal is to test your understanding of concepts on series circuits. So instead, you'll most likely be presented with values of different components for each resistor and then asked to solve for the other components. I'm going to talk about how to approach these problems. And speaking of problems, this video actually has two problems. So I suggest watching how I solve the first problem, then pressing pause and trying the second problem solo. I also go over how to solve the second one as well. Okay, let's get started. Okay, we're given 12 volts for a circuit and two resistors, but we don't actually know what the resistance is. Instead, we know that for R1, we have a voltage drop of 9 volts. And for R2, we have 3 amps going through it. Let's move this over to the side like we did for the other problems so that we can make a table. It's really important to make a table, especially in problems like this, and fill out everything that you know about series circuits before actually using Ohm's law. So what we're going to do is calculate these values again for resistor 1, resistor 2, and for the whole circuit, which we'll just say T for total. I'm going to just pull this up here for a second. From the diagram, we know that the total voltage drop across the whole circuit is going to be 12 volts. We also know that for resistor 1, the total voltage drop is equal to 9 volts, and that the current going through R2 is 3 amps. You can fill the table out in any way you want, but I like to start with things that are consistent throughout the whole circuit. So you know that for series, the current always has to be the same, meaning this whole row right here should just equal 3 amps. Also recall that for voltage, the total voltage is equal to all the voltages in the circuit. Specifically for this problem, you can say that V1 plus V2 is equal to V total. So you can calculate R2 in your head, or we can fill this out. So we can say that 9 plus V2 is just equal to 12 volts. Subtract 9 from each side. And then you end up getting that V2 is equal to 3 volts. I'm just going to box it and then fill out the table right here. Okay, so if you're looking at this table, you can calculate the resistance using Ohm's law, because remember that if you have two components of Ohm's law, you can solve for the third one. It doesn't matter which column you start with, but I'm going to start with R1 and R2 and you'll see why. At R1, we have V equals IR, and we can fill this out. So we know that we have 9 volts. The current is 3 for the whole circuit, and we're going to solve for R1. Divide each side by 3. 9 divided by 3 is just 3, so we have 3 ohms for resistor 1. I'm going to box this as well. So let's fill out the table. Again, you can do the same thing for R2, but use the values of 3 volts and 3 amps. At R2, we still have Ohm's law, which is V is equal to IR, but just for resistor 2. The voltage here is 3 this time. Current was always 3. And we're still trying to solve for R2. Divide each side by 3, and we end up getting that 1 ohm is resistor 2. Recall for resistors in series that if you add up all the resistors, you'll get the total resistance. So in this case, we can add up 3 and 1 to get your total resistance to be 4. You can also check your work by plugging in the values that you have back into Ohm's law. So let's go ahead and try that for the total. We're still going to use V equals IR, but just for the whole circuit. Remember that the total voltage was 12. We said that the current for the whole thing was 3, and that we calculated that the total resistance was 4. And in this case, you can see that 12 equals 12, so it worked out. I'm going to pause here so that you can try problem 2 solo. Hey guys, I hope the problem went well. Let's go ahead and review. So if you look at the circuit, we know that the total voltage drop across the whole circuit is 120 volts. Let's go ahead and fill that out. We also know that for resistor 1, the resistance is 20 ohms. We also know somewhere in the circuit, the current is 4 amps. It actually doesn't matter where this is labeled because for a series circuit, it's always going to be the same current. So for this whole row right here, we can basically fill it out as 4 amps. There's a couple things you can actually solve here. You can either solve for the voltage in resistor 1, or you can solve for the total resistance using the last column. I'm going to start by finding the total resistance using Ohm's law. So I'm going to use Ohm's law for the whole circuit. We know that the total voltage is 120 volts. Current never changes, so it's always 4, and we're still trying to solve for RT. So if you divide each side by 4, 120 divided by 4 is 30. So we have 30 ohms is equal to the total resistance. Also remember that the resistors all add up for the total resistance. So here you can say that 20 plus 10 is equal to 30. For the next part, you can use Ohm's law again to calculate the voltage for R1 or for R2. I'm going to start with R1. At R1, we have V equals IR again, but specifically for resistor 1, we don't know the voltage yet, but we know that the current is always 4, and we know that the resistance was 20 ohms. So then you calculate the voltage is equal to 80 volts. If you look at resistor 2, you can use Ohm's law again to calculate the voltage drop across resistor 2, or if you remember that the voltage drops all add up to the total voltage, then you can use that as well. So for example, here we know that 80 plus 40 should equal 120. Also, if you really want to check, you can plug the numbers back into Ohm's law and see if this equation holds true. So let's go ahead and try that. So for resistor 2, we again have Ohm's law. At resistor 2, we just calculated that the voltage drop was 40. The current never changes, so that's still 4, and the resistance that we calculated was 10 ohms. So 40 does definitely equal 40. And that is the whole problem. Thank you for watching. I hope this was helpful. Feel free to subscribe and like below.